Okay, calculus students, welcome back. Here are some more problems or solutions to the problem set 5.2 through 5.3. Again, I'll go through them rather quickly. So if you have any other questions, you can't quite pick up on any of this, make sure you send me a quick email and I'll try to clarify. One of these is problem number 43 from section 5.2. Now, this is one that it's very important to realize that I wanted to adjust the instructions, and the instructions did not include letting n be 4. They were written so you wanted to write the area in terms of n in a general value, but I don't want that. So basically, we're just going to do what we did on last week's video. We're going to chop this up into 4 parts, nice and equal. And then from there, we are going to find the lower sums and upper sums. Lower sums being the sum of all of these red rectangles, remembering that this one will be 0. The upper sum is going to be the area of these blue rectangles. Now, the base of every single rectangle is always going to be 1/4, 1/4, 1/4, 1/4, because it spans 0 to 1 and divided into 4 parts. The height of the rectangle is going to be determined by the function. So the height, for example, here is going to be 3/4 squared times 5. So find the upper sum and lower sum simply by those calculations. Hopefully that clarification or change in the directions will help. The next one to look at is up here at section 5.3, number 43. And this is when we're really just asked to use a lot of these properties of integrals. So what I would do in this problem is I'm going to separate it. I'm going to integrate just that first part, which means we can take the 2 out, integrate from 0 to 6 of x cubed. And then if I integrate the second part, that's minus 10 times the integral from 0 to 6 of x, then integrate the third part. Be the dx in all these. There's really a 1 right here. So now, based on the problem, if you look, you are told what each of these values would be. So once you plug in each of these values for the integral of x cubed, the integral of x, and the integral of just 1, you can go ahead and make that calculation, and you should be able to come up with an answer. And I'll let you finish that. Okay, the next one. We want the integral from 0 to 10, but we're given the function not in terms of an equation, but just in terms of data, a numeric approach. And another way to look at anything that's numeric is to turn it into a graph. So I'm going to take the time to just sketch some of these. If I get a quick sketch, and we know that the intervals in the x values are by 2, so of course that's 2, 4, 6, 8, 10. This is a technique you can always use anytime you're given data and you want to somehow get a picture of what's happening. Well, at 0, I think the function is up at 32. So there's the function. At 2, it's at 24. So I'm going to put a point here. At 12, it's at 4, it's at 12. At 6, it's at negative 4. So at 6, it's at negative 4. At 8, it's at negative 20. And this is obviously not to scale. And at 10, it's negative 36. Now, if I want to find, let's say, the lower sum would be basically on every interval, take the smallest value. Well, the smallest value from 0 to 2 is at 24. So I'm going to make a rectangle based on that. From 2 to 4, the smallest value is up here at 12. So I'll make a rectangle. From 4 to 6, the smallest value is negative 4. From 6 to 8, the smallest value is negative 20. And then from 8 to 10, the smallest value is negative 36. Because again, the lower sum is always going to be the smallest value or the least height rectangle on that interval. So this lower sum that I'm just going to call LS is basically going to be 2 times 24 plus 2 times 12 plus 2 times negative 4 plus 2 times negative 20 plus 2 times negative 36. If you do this whole calculation, I know it's tough to see down here in the red, that's going to give you the lower sum. The upper sum, well, I'm not going to do all of this for you, but if we take from 0 to 2, the biggest rectangle would be up here at 32. Here it would be at 24. From 4 to 6, it would be this one. From 6 to 8, it would be this. And from 8 to 10, it would be this one. That would be considered the upper sum. Just find out the areas of all of these blue rectangles. Again, some of them have negative values because they're below the x-axis. And that's going to give you the upper sum. You start to get a feel for a pattern if you had to do a lot of these. But don't be afraid to plot the points anytime you're given x, y values. And then hopefully you have a better idea of how to find these upper sums and lower sums. The last one, number 53, on section 5.3 also. We are given this picture, this information. Well, guess what I want to do? I want to make a picture of what exactly that means. So my picture is that the integral from 0 to 5 is 4. Now, I don't know what this looks like. Could be a rectangle, could go up and down a few times. I'm just going to make it a convenient kind of hump. So this area is 4. Okay? Now we're given some information, and we're asked to decide what we know based on that information. For part A, we are supposed to find the integral from 0 to 5 of the f of x plus 2. Well, in order to get that, I can use properties of integrals, knowing that I can separate these. This we know is 4. The integral of 2 from 5 to 2 is basically going to be 10. The reason for that, the function 2 is just a horizontal line. From 0 to 5, that area would be 10. So we get 14. The next part, we want the integral from 0, not from 0 to 5, from negative 2 to 3 of the f of x plus 2. Well, in this case, we just have to think, what does this x plus 2 do to the function? Well, it basically moves it back 2 units. So if it's just moved back 2 units, we get the same kind of hump. There we go. The same hump, same area, so it's going to be 4 also. And now for the final two. What if the function is even? Well, if the function is even in part C, then the integral from negative 5 to 5, we first have to realize what it means to be even. For this function to be even, that means it's symmetric with respect to the y-axis. So from negative 5 to 0, it's basically the same thing. So we can see that this is going to be 4 plus 4, which is 8. And then lastly, for part D, I want to squeeze it down here. Hopefully you can see it. if we want to go from negative 5 to 5 of the function, if it's odd, well, if a function is odd, what we know is it's symmetric with the origin, which means we just kind of rotate it. So if this is in the first quadrant, its image is down here. So now we're trying to look at this area. Well, it turns out that, again, an area that's below the x-axis is considered a negative integral. So this we consider to be negative 4. So we get negative 4 plus 4, and we get 0. So area would always typically be a positive number, but it can represent a negative integral if it's below the x-axis. I know this was quick, but you can slow it down and watch it another time. I know it's all on one board, so this is it. If you have any more questions as we progress through the week, please let me know. On Wednesday, look for a worksheet or a quiz to be posted, and I'll give you more information about that on the update. Thank you for your time, and have a good day.